All right, howdy folks. I'm gonna make some videos for us to be able to go through the different types of projectile motion questions. So starting with question type number 1, it says a ball rolls off a 1.5 meter high table. So I'm gonna draw a table, it's 1.5 meters tall, with a horizontal speed of 2.4 meters per second. Now when it says horizontal speed, that tells me that it's a Vx, and because it gave it to me at the beginning of the problem, I know it's a V initial or V0x. Sometimes I write it that way. Question is, how far from the base of the table does it land? So I'm going to draw a little sketch of what it does. This distance, dx, is what they're asking about. So in the x direction, I've got dx equals v initial x times t plus 1/2 ax times t squared. Now the good thing is that ax will equal 0 because gravity doesn't pull it sideways, right? There's nothing continuing to cause it to accelerate. So in all of our projectile motion questions, ax will be 0. That's nice, so that whole thing goes away, and I'm left with just dx equals v initial x times t. I know v initial x is 2.4, but I don't know t. So I have to go on a little side quest to solve for t. Let's see. So let's say dy equals v initial y times t plus 1/2 ayt squared. Let's see, it travels down by 1.5 meters. And it wasn't moving up or down at the beginning, it was only moving sideways. So v initial y is 0 times t, so that whole thing is going to go away. Plus 1/2 negative 8 t squared. Negative 1.5 divided by 1/2 times negative 9.8 is t squared. So t squared is 0.306. T is the square root of 0.306. Now that I know my time, I can plug that back in. dx is equal to 2.4 meters per second times the 0.553 that I just calculated. .327 meters, and it's meters because the meters per second cancels with the seconds, and all that's left is meters. So dx equals 1.327 meters. All right, that's it for question type number 1.